one request to GraphQL to be for data loader to or batching in general to work. Like it's not going to pause. And I forget how it affects with subscriptions. I think the subscription thing in Absinthe like knows that a bunch of stuff is subscribed, and so like if you have a bunch of users all subscribed and they would do the same thing, it only does that once. And I think that just works even without data loader, if I remember correctly. They cover this in like the multi-day training that they do for the national conferences. So if you still have questions if your API is doing Absinthe as efficiently as possible, just do the multi-day GraphQL training at the like National Elixir Conf in well, September. It's pretty far away now, but I don't know if they offer another one besides the national. Because it's usually like a 1 day for like the regional ones. And this stuff is sort of covered in the book too that they put out. So
yeah. Yeah, I'll have to look into the book some more. I know that I don't think I read the entire book, but from what I remember, the part where it's talking about data loader, I think I thought from reading it that what they were showing you how to do kind of required one of the databases that Ecto was compatible with.
Data loader can be separate, but most people would use it with Ecto. I think is the difference. And even if you can't use data loader, you can just drop back to the batch one. But the nice thing about the 2-day train is like they kind of be like, why do we have data loader? So they start first with, here's GraphQL. This is efficient. Let's do batching. Okay, this batching was really wordy. Let's use data loader. Oh, that was less. Oh, if we have Ecto, it's even less. So like, it's sort of like if you get to the point where you understand batching, you then can transition to data loader, assuming that like your queries are feasible. Like like it turns out that you can actually reduce the how many requests you're sending to Elasticsearch. If it turns out that's not the case, and like the way people are using your API doesn't, like they're not trying to get back pages of results where you can do like an index with a filter sort of query from Elastic, it might not matter for your API performance, but it's something to think about.
Okay.
It's something you totally can put off too. Like if you don't have load issues, it doesn't matter. If you didn't do it like the most batchy, efficient way. Don't optimize so you gotta.
Well, I recently I did something else to help with load issues. But yeah, data loader can be separate of Ecto. Then maybe I'll look into it. So actually on my to-do list is to actually figure out how Ecto implementations. You know how you make like an Ecto library for like a specific database?
Mm-hmm.
Yeah, so on my to-do list was to look into seeing how possible that would be for Elasticsearch.
It also feels SQL-y or Mongo-y, because like there's kind of keyword support to support Mongo, but like if Elastic can't get wedged into there, it's not a good fit.
Okay.
Kind of surprised no one tried to do Elastic, but I mean someone did kind of a joke one for like the GitHub API, so it is possible.
Well, there is a repo out there for somebody who made a. I think it was a Ecto Elasticsearch thing, but it wasn't really documented. The last time it was many months ago.
Mm-hmm. So,
and when I was looking at it, I didn't feel confident in like reading and understanding the code base without really documentation.
Mm-hmm.
So I didn't use it.
Yeah, I guess since we have more. So you said you have a job. Is the place you? What was the name again?
2DA.
Okay, 2DA. Is it hiring?
Yes.
Okay, you're a startup. Are they actually paying in real money?
Yes.
Okay. Okay, new person. What's your name?
Steve.
Hey, Steve. What's...
I'm so new with Elixir.
Okay, then previous programming background.
Embedded systems, Java Spring.
Okay, so like the Java on the embedded systems or like C for the embedded system?
Totally different lines of work.
Okay.
Yeah, did some, you're talking about databases, good job spraying, hibernate, JPA and stuff. Getting into Haskell and Lisp kind of stuff, so yeah, I just want to hear about more functional stuff.
The Haskell meetup here in town is very good.
Okay, yeah, I saw that. I'll be on that.
Okay.
Just hoping to learn, catch some side effects for you guys.
Okay. So, is the place you're currently working hiring?
Nope, I'm between jobs right now.
Okay, so you're looking.
Yeah.
Okay. So, talk.
Yeah,
Or just, are you going to, like, it sounds like you're interested in a lot of languages.
Yeah.
Are you going to ElixirConf next week?
Didn't know that, but I'll
Okay, so it's pretty late to get a ticket if you're unemployed. Like, don't worry about, like, I know you're not in a case where you want to spend hundreds of dollars to maybe get a job.
Oh, okay.
But just so I know, I will try to write down the job board and bring it next month, or just try to post it to the thing so that you get the benefit of it since you're looking.
Awesome, thanks, man.
I try to remember, DM me on Meetup using the Meetup message system so I remember you, so that I can say, when someone asks, is someone looking, I can, try to connect you to them, okay?
Awesome.
Yeah.
Thanks, man. What's your name?
Luke Imhoff. I run the Meetup. So,
Okay, sweet.
okay.
And we're hearing, so I'll bring your info too.
Okay.
So, like, probably send you like an email or something, or probably tomorrow.
Yeah, I'll email you my resume. What is it?
John.Jacob.
JACOB.
Yes. At 2da.us. Yeah, and then you can CC that to my supervisor, Anthony. .SHULL at 2da.us. And then can I get like your info?
Yeah. Name's Steve Anderson. Want to get your email address?
Yeah.
Yeah, Steve at newsletter.com. POOTLAER.
I think so. Yeah, you can send that. And,
Oh, sweet.
Okay. So let's start the real meeting since we're done with the intros. Hey, people online, hopefully you can hear me. So we are here at Capital Factory. They are our sponsor because they give us the space. Yay, space. They would like you to look at their events and maybe join for membership so that they get money, which is how we get this free space. I'm Luke Imhoff. I'm known across the internet as Chronic Death. I work at Docker in the R&D department. Yes, that's a change. I used to work on client projects. Now I just do R&D. It's nice. I created IntelliJ Elixir, the Elixir plugin for JetBrains IDs like IntelliJ, RubyMine, WebStorm, etc. And this month, I'm giving you a preview of my talk for Lone Star ElixirConf, which is actually next week, and usually the videos are very fast. So you're only getting like a week preview. This is things you might not have tried with Ecto. Even before the split of Ecto into Ecto and Ecto SQL in version 3, Ecto could be used with or without a database. Without a database, Ecto can still be used for casting validation. When I say cast with Ecto, you probably think Ecto.Changeset and Ecto.Changeset cast, but that's not the source of Ecto's casting. Instead, Ecto.Changeset cast is internally using Ecto.Type. Ecto.Type is a behavior with 5 callbacks: cast, dump, equals, load. Do you want me to turn off the lights? Is it easy enough to see this? Or do you want the lights?
Yeah.
darker would probably be better. You make it a little darker.
Right here?
Yeah, smack the top light, and it should kill it. Hey, there we go. Cool. Okay. Cast, dump, equals, load, and type. I always forget if cast, dump, load, and type are talking about the external Elixir or adapter type, so I made this nice table. Cast is going to pull in external user input and spit out an Elixir type. then dump is going to take that result and dump it to the adapter. I say adapter because it doesn't necessarily have to be the database directly. Like in the case of Postgres, you're actually going to dump to the type that Postgres understands, which then may be munched again before it goes to like the binary type that the actual Postgres binary connection understands. Load is going to go in the opposite direction and suck it out of the adapter and back into Elixir. And type just says what the adapter type is so that you can have the difference between like, I'm going to use a datetime struct, but it's going to be the datetime type that Postgres supports natively. And so the type thing would say datetime as a atom instead of the struct. If you're wondering how the callbacks are used, for insert, you're taking in the external input, casting Elixir, then dumping it into the database adapter. For read operations like get and all, you're reading the adapter type from the database, loading in and loading into the Elixir type. For update, you're combining those two streams. So you're loading from the database for the pre-existing value. You're taking the external value. You're using equal to see if semantically they're equal. And the reason for the semantic equal is if you have a type where the equals operator that's just in Elixir does not work, you can do this equals operator on the type. And the reason for this is like the decimal type to do like big decimals doesn't double equals on Elixir because you can't actually override the operators in Elixir. And so instead, there's this equals operator that they add to Ecto.Type. And the same thing happens for the datetime struct because structs are comparable, but they don't compare correctly because like the number of microseconds might be different. And so equals papers over that difference when you might have different granularity. So if they are equal, there's no update. If there is one, it dumps it. Now, you've seen how Ecto.Types can be used. Let's see an actual example. Our use case is converting hashes. Hashes are hexadecimals so that people can read them. So this is like a git hash to be like a commit or something, or anything else where you're like the hash represents the value, you know, like a pointer to the value in the data store. But the hash itself is really a run of bytes. So in Elixir, we have a better representation. We're not using the database yet, but for the adapter, this would be a byte A or binary type in Postgres. A byte A is short for byte array. So binaries are great for pattern matching, but they have some problems. For our project, we're using Phoenix for the UI. So we'd like the Elixir type to implement string chars, Phoenix HTML save, and Phoenix params. We'd also like to restrict the length, but while the type binary can implement protocols, different ways of using the binary type because it's such a simple type of just, you know, a run of bytes that you can't re-implement the protocol more than once. So there's no way to be like, when a binary is this long and has this prefix, I'm going to do this to it. Because once you implement the protocol once, it's gone. And so we can't look at protocols, and we can't restrict the length. Like, if we say it's a binary, we can pattern match on the binary, but we'd have to pattern match everywhere, so it's hard. We would be constantly checking in every one of our function heads, like, is this the right length? Is this the right length? Is this the right length? And as a general design principle, you want to like check your data external once, or like external in the sense from the database or from actual users, and just be like, from then on, be like, yeah, I can trust this data. And so normal binaries aren't good enough. To be able to implement protocols, we need an Elixir representation to be a struct, because structs are the only user-defined data type in Elixir, really. Everything else is like a base built-in data type. So we wrap the original binary in a hash struct. The bytes binary has a size that we pattern match out. We want to prevent incorrectly sized binaries from being directly set in the hash. So we also record the expected byte count in the struct. This is this slight paranoia because we had a a fairly large team of like 15 people with us each working on different parts of CodePass. And so this was just to double check our work. It's not strictly necessary, but it did catch bugs. So it turned out to be worth it, even though it's a little bit extra, more data than we really needed. As I mentioned, we had hashes of multiple sizes. So we made the hash module be pluggable as a behavior. So depending on how familiar you are, I always translate behavior to a interface in Java is the best way to think about it. Not as enforced, but the best way to do it is like, it's the closest thing we have in Elixir is like, you can check that another module implemented the callback, so like the methods that you're expecting. For the full hash, it contains the byte count for the hash behavior. Ecto-type callbacks then defer to that hash module. The hash module itself defines the shared hash struct. The implementation modules, such as full hash, implement the byte count callback to restore byte count field to a specific value instead of the range that the base one allows from 1 to 32. Cas2 deals with 5 types of input. The first type of input, which all Ecto-type cast implementations must handle, is the value is already cast and we're just going to pass it through. You always want your cast functions to be idempotent, so you can just call them over and over again, and it doesn't blow up. You can see the double check of the byte count in the pattern, checking both the byte count field and the byte size in the binary pattern so that calling code can't fix hashes of internal, can't try to trick it by passing hashes of internally inconsistent size or that are different from the declared size for a field in the Ecto schema module. So what this caught was like copy and paste errors where like we started with a file where we had hashes of one size and then we copied it over to another one and we forgot to change the value. And then all of a sudden the hashes, because semantically and in the domain knowledge, like the domain model, 32 and 20 bytes, even though 20 is a truncated form of 32, people using the 20, they mean something different than the 32 length. And so this way we were able to catch those differences and like trigger like, oh, we're accidentally confusing fields. Or we introduced a bug where we assigned the wrong field to the wrong spot. The second input was a plain binary, which we need to handle to interact with external APIs. Its size can be checked against the required byte count for the implementation. The third input is what you'd think of as a hash, is the human readable OX prefix hexadecimal string. It is important that the non-human readable binary pattern appears first because we had a bug. The character 0 in ASCII code is 48. The character X in ASCII code is 120. Putting those in a binary, extracting the number and turning it back into hex, so that any hex that started with 3078 in hex match the OX prefix in a string. Since the so we had to make sure that the order of the patterns were correct first. Otherwise, we would think that we were casting strings because the pattern for binary doesn't say a size. It's just like eat the rest in it. Binary just means it's bytes. Like you don't have a bit string. You know, like you have exactly some multiple of 8 bits. That's all binary is telling you. And so this ordering matters so that we don't accidentally think that an actual binary string from an external API or from the database is a human written OX hexadecimal number. We could have checked the encode known length of the hexadecimal digits by like multiplying out that each hex digit is 2 characters wide, but doing that felt like I had to put a comment of like, why was this number here? Why was it 64? And so I just felt it was better to have the separate function that used the more explicit string length operator to show exactly what we're checking against. We want the bytes at the end and want to skip the, we want to get bytes out of this and want to skip having to first convert to a really big integer and then convert that integer back to bytes. So we use base decode 16, which does the conversion directly on the hex encoded value without having to first turn into an integer. The fourth input to cast is a normal Elixir integer. really expect user external inputs to be in integers, as it's not really correct to think of a hash value as a number, because like leading zeros matter for hashes, but they don't for numbers. The only reason we did this is it makes testing easier. So that we could use sequence from Ex Machina to just generate hashes serially, and so cast them to check the type padding was correct. When casting from an integer, the important thing is to check the range, which I calculate based on the byte count that's supposed to be there. Dump is simpler. We only need to extract the bytes for the binary format used in the adapter. The comment hints at the bug that needs to be prevented. Copy pasta for the wrong hash type being directly set, as happened in some of our tests. Using the wrong type of hash could make tests fail or more perniciously accidentally pass. So doing these checks made sure that code in different parts of our code remain consistent. Load approaches the bugs from the other direction. We have a lot of data and a lot of ways to write it. In some cases, we're using SQL to directly set one field from another, such as when doing data migrations that involves foreign keys. We want Ecto.Type at runtime to verify the data we're getting out so that we catch those bugs in our raw SQL as soon as possible when we boot other code. This way, we're having different parts of our application double check each other and not just trusting that the data is correct. Because when we're loading data in from those SQLs, we have to count the database as an external input at that point because we did a transformation on it in potential code that could have a bug. OK, so I said Ecto.Type was useful when you don't have a database, but I just showed you dump and load, which are definitely used in the database. So how did we use hash full cast without the database? We used it to check inputs without round tripping to the database. This pre-check is important because repo get and repo all don't pass through a change set. So we would have had to pass bad inputs. And when you pass bad inputs to anything besides string types or like strings that can be converted to integers in Postgres, it blows up with an exception. And so actually being able to validate your input with these Ecto.Types is really useful for any of your queries. It also means that we could use hashes to look up in non-Ecto databases such as stables used internally for caching, or even in-memory maps, or remote APIs. Let's move on from without a database to when we are using a database. You can't have a database without first creating it. So a logical point for talking about Ecto with a database is the migrations. Create table creates a default primary key called ID. In Postgres, it is a serial. A serial is an automatically incrementing big int. Knowing it's a big int is useful if you decide, I don't need a primary key, and you're like, ooh, I really needed a primary key, because you have to redo this by hand. When we want a non-integer primary key, such as the binary hash or UUID, we need to tell create table to not create that primary key. There's no way on primary key to set it to like be a different type. It just is on by default with primary key true as a default option, and you can turn it off. But then we need to mark the field that we want to be the primary key as true. It actually is possible to do composite primary keys by marking multiple fields as primary key true, and it just transforms the DSL to the proper SQL to mark all those fields as primary keys. It works. And this primary key also automatically does the primary key index, so that's just something that Postgres does. It's not, you don't have to like make a manual index here at the end. It'll still work correctly. For join tables, neither foreign key is really primary, so they don't have primary key true. Instead, we need to do what that primary key would do manually. Do the null false, and then a unique index on the pair of the two foreign keys to the join tables. In our case, the join was used to look up in either direction, so we create two indices. You see there the order of the second argument, which is the columns involved. So one is nephew, uncle, and the other is uncle, nephew, to go which direction you're doing the join from. Because the order for a multi-column index in Postgres, the order of columns matter. It is allowed to use the prefix of an index if you don't have all the columns, but it's not allowed to swap the order because it's sort of like a tree. And so, you need to be able to match the first one first to use the rest of the subtree. You may have noticed that the nephew hash and is a foreign key, while uncle hash is only a byte A. This is because we're getting data from a remote API. So we know that the nephew is connected to the uncle before we necessarily know about the uncle. Like when you're hitting a remote API to get your data, you're going to know about one side first, because there's no way, not every API is going to give you a fully connected graph when you query it, just because it has to cut off the data somewhere. Like some JSON APIs will guarantee a fully linked result, but not every sort of API does that, just because it can give you more compact results by having one side just be pointers to the other data, in our case, hashes. To keep track that we haven't fetched the uncle yet, we can use the uncle hash. We can't use the uncle hash column because we do know its value. So we can't just be like, when it's null, that means it's not fetched. So instead, we add a column called uncle fetchstat where we default it to null so that we can be like, oh, hey, we know that number, but we actually haven't fetched the row for that uncle in the blocks table. We need a way to, but then we have the problem of we have that marker, but this table is huge. Hundreds of thousands to millions of rows. And so we need a way to quickly check where are those nulls when we're in development, we're in IEX, and we do Control-C, Control-C, it crashes. We purposely crash the node to stop the app from running. And we come back up, and we don't want to sit there for minutes for a query. So we need an index to figure out how to restart our work. So we can set up with what Postgres calls a partial index. This is an index with a where for all rows where the uncle fetchstat is null. We came to this pattern because, like I said, the timing to do, we first tried to do what SQL calls an anti-join, where you're like, I want to join these things, but be where like the one side is null. So it's like you're doing a left join, and you're like, if this is null, oh, that must be missing. So every sort of missing query we could come with like an anti-join or an accept query, minutes, just horrendous behavior for the size of our database. But doing this, partial index, seconds, way more acceptable. You don't have to directly index the column values, instead can index any value computed from the column rows. We create a unique index on the lowercase version of usernames to allow case preserving of the display, but case insensitive uniqueness without the need to change the collation of the column. So like Postgres, and I think MySQL too, you can change what's called the collation of the column to be like, I'm going to type in text, but act like you could order when you didn't care about case. But like that's annoying to switch the column. And this way you can just make it the index work that way and make sure you don't have collision. So you could preserve how people capitalize their email address, but compare it lowercase how you're supposed to compare email addresses. You may have noticed that you've seen the timestamp type UTC underscore datetime underscore USEC already. For more standard timestamp call, the type key is used to override the default type. By default, null false is set. But I've gotten the habit of explicitly putting null false or null true in migration fields to show I thought about the nullability of the column. Because a lot of times, I join a project and I'm going through and we hit a bug of like, oh, this column should have been null false, it's not. Did we purposely make that decision or not? So I'm just now, any new project I start, every column, null false, null true. I don't care what your DSL says the default is. I always put it. And a lot of times I'll put a comment of like, why did we decide this was null true? Or why did we decide this is null false? Mostly document the null true because I feel that's more of an exception. With the type option, the Ecto.Type is naive date time. If you want Elixir to know the database is using UTC, you need to explicitly use UTC date time for the Ecto.Type, and you'll be able to use date time in Elixir. In Ecto 3.0, the USEC suffix was added to say that you expect microseconds to be included, because in 2.0, it was a problem that some of the adapters didn't have microseconds and only had seconds, and some of them didn't. So they said in 3, we're just going to be like, everyone only has seconds, you have to opt into USEC. So like a lot of my older projects, I ended up changing the type to be USEC to preserve the old values having USEC. But for new projects, you have to make the decision of, do you care about microseconds or not? Like human interaction, probably not. But for ours, where we're doing a lot of gathering data from external APIs, having that USEC let us see the ordering of inserts from different API calls, so it was still useful for that purpose, even if like actual human interaction doesn't matter for that speed. If you need to schedule people or your calendaring system involving people, I highly recommend you don't use UTC or naive datetime, but instead record the times that are specified for the user. So one, you can display it back to the user, but two, you can properly handle conversions between users, and three, conversions when the local time zone decides to change the time zone rules. Like that happened in Florida recently. It happens in counties in Iowa a lot. We had when daylight savings time changed, you know, back when George W. Bush was president. So like these things happen, and if you're doing anything where people are like making appointments or scheduling work with each other, keep track of the time zone they think the appointment is, not just UTC. To record the timestamp with the time zone is already supported by Postgres with the time zone TZ type, but Paul Schoenfelder's Timex Ecto library has improved datetime TZ type, where like you create a new type in Postgres, and that records both that timestamp TZ and the human readable name of the time zone, because like one time zone offset of like -5, you know, can have multiple names. So, like the actual time zone name isn't CST or CDT. It's like America, Chicago, and so on. So you can record those things, so you can present it back to the users exactly as they think about it. And that can be super important if, you know, they used to both be -5 or like certain time zones on the -5 do or do not do daylight savings time. So knowing it's America, Chicago versus one of the other ones up and down the line in like Canada and like in South America can matter. Postgres has another useful feature for scheduling. You can create an exclusion constraint using a GIST index and the ampersand operator on a range type. For us, that was an int8 type because we cared about excluding ranges of numbers, but you can do the same thing on a date range to exclude ranges so that you make sure that people, you know, are only on a project for a certain date range. So like if you're doing Gantt charts where you're like, this person can only work on these days and they can't be double scheduled, you can use this so the database automatically rejects double scheduling. Before we found this, the way we always thought of doing this is like, you know, you have the two endpoints as a manual data type that you're putting in a separate date times, and you're doing like less than or equal to, and you're doing like, you know, you're kind of doing like polygon collision checks. And Postgres would just do this super efficiently if you pick the right data type. Like whenever you're like, we're doing this thing, you gotta ask yourself, has anyone else had this problem? Is this a really common problem with programming? And then you're like, Postgres probably has a data type for it. The scheduling usage shows the first complex constraint, but in general, because we had multiple writers reaching the same database table over multiple code paths, we wanted to make sure that the database was enforcing any validations as constraints. This started simple enough. For a domain example, a transaction can be in a pending state, in which case it isn't associated with a block, or not pending and assigned to a denormalized block number. Unlike validations that can be skipped because of imperative logic, so that you like never call the validate length if some other rule, you know, you can have a little if or an unless that just makes it not be called. Check constraints are always run. So there must always be some way to calculate true in any valid state and false in any invalid state, which means without causing an error, which means you can end up with some pretty complex rules if your table represents multiple states for a single field. I got in the habit of writing out truth tables to check my work so that I could explain how each combination of columns could occur. This happened after having a bug in this code like 3 times. So like I just started like, okay, explain your reasoning. But you don't want to write out all those combinations in the actual SQL because it's not very efficient for the database to run on every update or insert. So I included the Carnot map to show how I simplify the truth table and link to Carnot maps because not everyone remembers what they are or knows what they are. If you have like an actual CS degree and like one of the math classes like talks about Carnot maps as a way to simplify Boolean logic, super useful. It lets you write less code to do the same if and ors combined together. Moving out of the setup of the database with migrations, we start to get to the actual work of inserting, updating, and reading the data. our application functioned as a way of caching and exploring data from an external API. So that means we had an extract, transform, and load, or ETL process, and involved bulk operations on the database instead of single row operations. Active bulk operations all the all suffix. Insert all, update all, delete all, etc. Looking at the arguments, none of the operations take change sets, which means we can't pass change sets and get back validations. Focus on an insert all. Entries can either be a map or keyword list of field names pointing to their values. We would like those field values to be validated first. So how do we do that? Let's plan out our API. We want to specify the Ecto schema module that has the changeset function once. Unlike the changeset functions, we don't want to pass one map of params, but a whole list of maps. We also need a way to call a changeset function that isn't called changeset. So we take inspiration from Ecto's other APIs and add a with option to override the changeset function name. This with is used for associations where you can say that an association is validated with some other function besides the name changeset. We're going to extract our argument options, validate with the changeset function, and reduce the changeset to a single OKR tuple. Let's zoom in to see those steps and details. This is still pretty dense, so let's fill it in with some specifics. We'll change Ecto schema module to address. We'll fill in changeset for changeset function name. Now that the module and function are no longer variables, we can replace the apply with a normal call, which makes it more obvious that we're validating each map params in the list separately, and we'll end up with a stream of change sets. We need to convert those change sets into either error or an OK tuple. We're going to use an all or nothing approach, so if we encounter an invalid change set, we'll switch to an error tuple. From then on, we ignore any valid change sets and only accumulate more errors. The only way to exit the reduce with an OK tuple is for all the change sets to be valid. The reason we took this approach is thinking about like how to separate all the params for a response from one remote API response. We would have to recompute the data dependencies between like the related fields, and that was like too hard. And so we're just like, it has to all work or it doesn't work. And also we kind of found that with taking in the remote API, we either found like a general class of bug, like the remote API was giving us data that they didn't document as giving us. And so it wasn't a big deal to throw away an entire batch of data from the remote API to try to get the other ones through. It was better to just see the bug, fix the bug, and then get the remote API again once we fix the bug. We can extract out the map that insert all needs with the changes field inside of changeset, because this is guaranteed to always be the cast form and only the fields that are valid. I really love that changeset valid is a field inside of a function that needs to be called, because it means that I can have code that checks for validity without rerunning the validators. Like there's other APIs I've used in other languages where like, if I want to check if something is valid, I unfortunately call the validators again. It didn't just record the result and ask for the cache proof value. It also means we can do pattern matching. With the list of changes maps, we can call insert all. We had multiple tasks running the insert all. The remote API could supply the information for this table to any number of those tasks. So multi-writers all going at once. So we ran into errors like this where we're violating unique constraints because insert all doesn't use change sets. There's no way to convert the Postgres error to a change set error. Thankfully, insert all supports a conflict, target, and on-conflict option, so we can convert an insert into an upsert. This works both on Postgres and on MySQL. It also, of course, works on Mongo because like the term upsert comes from them. Using replace all for the on conflict led to problems where the foreign key constraints, though we were thought we were deleting a reference to the primary key because the check doesn't check whether the value is the same or not. So even though we were recording the same value for the primary key, the fact that it was being replaced said that we were violating the foreign key constraint, which I didn't expect. I thought like, oh, Postgres would be like, it's the same value. It doesn't really count. No. You change the column, it thinks it's changing. When this happened, we shifted away from last right wins and instead thought of specific business rules about each column should be updated. This was when Ecto.2 was still out. In Ecto.3, there is, I think there's a like replace all except primary keys. You can kind of avoid this in that case. But it was a good use for us to do better on conflict rules. The general structure of an on-conflict Ecto query is a from of the insert table with a nested update set. So this is the same thing you'd pass to update all. The individual set arguments are updates to columns. One is using coalesce to pick the non-null value. Although coalesce is supported in Ecto.3, Ecto.3 does not understand the excluded meta variable. So when you have an on-conflict, the new row, at least in Postgres, is called excluded because it's being excluded from entering the table. So new row is called excluded. Old row is just going to use the address, the question mark variable that's going to match the table name that's the table you're inserting to, which is why we're using address.contract code in the bottom there. So we use fragments so that we can use SQL directly. Like I said, we need to use question mark defined because we need to use the Ecto column reference address contract code because when Ecto makes actual SQL, it usually aliases to compact names. So like for address, it's probably going to pick like A0, or it might pick T0 for table 0. And so we need this question mark so that we know that name and don't have to like just hard code and hope it's T0 and they haven't changed the rules for aliasing in Ecto. It also makes it so that we can nest this stuff together, that sort of thing correctly. The other pattern that we found useful was to correlate updates. In this case, we're using greatest on the fetch coin balance block number to take the most recent block number between what was already in the database and what was being inserted. Greatest is a nice operator because it's like max. So you're like, I want the max of 2 numbers in SQL. And you're like, I'll use max. No, max is the max of that same column in 2 rows. If you want the max of just 2 numbers, like 2 columns next to each other in the same row, that's called greatest. And it hasn't always been there. It was like a Postgres extension. I think MySQL also supports it, but it's technically not on the standard, or it's like in one of the higher SQL numbers that not everything supports. But it does work in Postgres, so it's very helpful. The other way to do it, if you don't, greatest is like, you have to do this thing where you self-join to be like, I'm going to find the max value and then like check against the other one, and so it's much less efficient than using greatest. Or you end up having to use case, which is very wordy. We use case to emulate an argmax. That is, we want to pick the column that correlates with whichever the excluded or the current row that was in greatest below. So that's what this case is doing. This way we can both record when did we get this most recent value and what was the value, and we can move them together instead of last right wins. The reason we want to do this is because there's multiple writers. They're each doing separate calls to the remote API. So even if the 2 writers read from the remote API in order, they both could take a different amount of time to process, and so their order could shift. And so we want our on-conflict to always work that we get the most recent data for what we think the balance of a user's account is. Great, that fixed everything, right? Nope, we got this error. Even though on-conflict deals with a row already existing, Postgres does not let duplicate rows in the same insert statement as it assumes that is a likely bug. Like there's actually like a note or warning box in the Postgres docs, like, if you see this error, we're not going to let you bypass it. You probably have a bug. Please figure out what happened. I like that. Like Postgres is stopping you from shooting you in the foot. But it doesn't mean we have to figure out how to fix it. So how do we get around it? We started to use maps and map sets with explicit merge rules to ensure that we wouldn't have duplicate params being before calling changes lists. I recommend avoid using enum unique by because it can throw away the differences between non-unique keys. So if we say like unique by 2 columns and we just ignore like the other 7 columns, that means we're not checking that like it makes sense that that the values are the same or their differences don't matter. And so do not use unique by because you're going to probably hide bugs from yourself. And it'll be really hard to spot later. In our specific case, we had so many code paths being able to generate address references to be like, oh, here's the money coming here, here's the money coming here, here, here. Oh, you got money because you did this work. You got money because someone gave you money. You have less money because you gave money to someone else. And there was a bunch of different ways that could happen that we actually ended up extracting all those rules into one module, so those business rules had their own module. It wasn't just something mechanically we did anymore. We're like, here are the business rules that we can audit in one place. It was important that that the in Elixir merge rules for those two addresses for all the fields match the on conflict rules. Because if you think about it, you want the database to do you want a write to the database and then the on conflict rules to make the same choice you would make at runtime if the two updates came at the same time and you were doing them, because you can't insert both rows then. So you have to make sure that your rules in SQL and your rules in Elixir work the same. We got rid of unique index violations and duplicate row errors, but now we get deadlocks, which I didn't even think was possible in Postgres' multi-version concurrency model. I'm like, multi-version concurrency is like, every time you change a row, it has a number, that number's hidden for me, and like you get to the end of the transaction, it's just like, does my number match the highest number for that row? Okay, good, it commits. No, deadlocks can occur, because when the actual fight happens, a lock gets taken so that no one tries to change what the highest number is. To fix the deadlocks, we had to make sure that the insert alls in the different tasks wrote the rows in the same order, which means Pixie picking an arbitrary order and sorting all the writes to the same table in that order. I say the order is arbitrary because the unique key of an address is a hash, and hashes should be cryptographically secure, which means they should throw any input values to random places in the bit space. And so we can't say that order is like the people that open an account first are first. No, we're just saying that the order is stable, so that the order that people take locks, like this gets down to the level of normal deadlocks with mutexes when they do the bank account example of I'm transferring money from A to B, and B's transferring money from B to A. We need to make sure that the locks get always taken in A-B order for either of the people transferring money, so that A doesn't take its lock and then try to take the B lock, and B doesn't take the B lock and try to get the A lock, and they just deadlock each other. Postgres, thankfully, the way it does it doesn't just freeze the Postgres server, it says this deadlock message. Good job, Postgres. But it's still something you have to fix, or otherwise your code's going to have to keep retrying over and over again, which is a totally useful strategy, but your ETL process will be much slower. If you want to learn about how I figured this all out, I put it as a blog post up on the Dockyard blog right there. So far, we've only shown a single insert all, which can only insert into a single table. Insert into multiple tables in one transaction, you can use Ecto.Multi. Ecto.Multi has similar calls to Ecto.Repo. For bulk operations, the functions we care about are delete all, insert all, update all, and run. All steps of multi need a user-specified name for that step. This is used to report errors, which is very helpful. But it's also used for the keys in the changes so far. So the output of the returning statement from delete addresses will be in the delete addresses key and changes so far. So if you wanted to do something with the rows that you deleted, okay, we update our database and we now need to update PayPal that those accounts are gone, you could use the changes so far to do that, to hit an external API. Multi-run is the most flexible step for multi. It can be used to take the output of any previous step to do dependent database calculations, but it doesn't need to affect the database. Like I said, it can do anything. Update your ETS tables, update in-memory caches, send messages to processes, and do remote API interactions while still being in the transaction. So you could try to talk to PayPal, and if it fails, you roll back the database migrations too, because everything is in the repo transaction. And that way you can kind of do sagas. I mean, there's hex packages to do distributed transactions, which are called sagas. This is a step towards that direction of making sure your external data sources with remote APIs that you have to write to match your database stuff that you're keeping yourself. Multi is like a stream in that it doesn't do anything until you pass it to a different API. In stream cases, those are enum functions. In multi cases, that is repo transaction. Part of using Ecto.Multi or any operator in the same transaction is ensuring the ordering that primary keys are inserted before any foreign keys that point to those primary keys. As long as you're using references in your migrations and true foreign key constraints in the database, it shouldn't be possible to have data dependency loops. The order of your multi-steps should be able to match the order of the migrations that set up the tables, as you can't create a table with a foreign key to a non-existent table. Having all the table validations and multi-calls in one module led to over 1,500 lines of code in one file, which was just way too much. Inside the file, there was a lot of repeat patterns, which to me screamed a refactoring opportunity to extract modules and a behavior. So like going back to like the equivalent in Java, this would be the equivalent of like noticing that you can pull out an interface and make a bunch of separate classes instead of having a bunch of modules with like the same prefix and a different suffix and doing manual pattern type dispatch. Ecto schema module callback is used by the validation layer to validate params across all runners before any runner server. So we're going to split up the work, but we still want all the validations to happen first, because if we can reduce load on the database and not like, I'm going to try to insert this table, then I'm going to validate the second table's results. Oh, it failed. I'm going to roll back. Like we want to minimize the delay of hitting the database as much as possible and minimize useless load on the database. Like our databases are running at like 60 to 80% load while doing like empty database to like getting all the data from the remote API. Like we want to minimize those as much as possible. So we validate first, so we're not hitting the external APIs, including the database, until we absolutely need to. The run callback mimics multi-run, but simplifies the process in that only the changes list for that specific Ecto schema module is passed to the callback instead of each runner having to pick out the correct changes list. Since the run callback both takes in and returns a multi, it doesn't have to do a single multi operation, but any number of them. Because any multi-call, multi-delete, multi-update all returns another multi where like it just is aggregating the results, the same way the stream functions do. We found changing operations under runners useful for two different use cases. Before updating the runners table for any anticipated updates in an upsert, or to be like, inserting these rows could invalidate prior data. So like our remote API, we treat it as an eventually consistent data store. Like we couldn't necessarily trust that it wouldn't change its mind later. So even though we have Postgres, we have ACID, we are a consistent data store, we're mirroring an eventually consistent data store. So we have to be ready to be like, oh, that what we recorded is wrong. So like we're going to invalidate these results, but we'll keep them for historical records to be like, our eventually consistent data store changed its mind. Maybe there's a bug in it, and we need to know that like something bad is happening. So this way we like push the old results to the side. We say that the eventual consistent store's consensus is gone. We keep the old data. We then do the import what it thinks the real data is now. And after the fact, we normalize the data. The normalization in our case was mostly to make the actual queries done by the GUI faster. With all our validations and multi-runs separated by tables, we could declare the data dependencies with a simple list for the order. This is 13 tables in one transaction. And we ran into issues with the transactions timing out even after 2 minutes. Like we went back and forth, like 2 minutes didn't work, okay, let's go for 10 minutes. And we still sometimes had problems. So most of our timeouts were due to queuing, which you can actually see in the Postgres log. If you enable the server log and set the deadlock wait timeout to 1 second, it won't say you have a deadlock, but it'll be like, you have built up a queue. Maybe you're going to have a deadlock. And it'll say all your processes, which is how the different workers for Postgres are handled on the server as separate OS processes, or the process IDs for the threads in Postgres, and threads have PIDs on Linux. So like it'll say like, these are all queued up. And from that we could tell like, oh, Everything is just trying to use the address table because those are accounts. And the reason for this is they all were holding not exclusive locks even for writing, but just share locks, because every other table was trying to hold the share lock to be like, I'm foreign key pointing at that one, please don't delete it. Like, even because Postgres doesn't know that we were never going to delete that row. It has to assume that the row could be deleted, so it has to take a lock. There's no way in Postgres to be like, this row will never be deleted under normal operations, you don't have to take a lock. That just doesn't work. It always takes a share lock for foreign keys. And so so you could run into a similar problem if you have a bunch of other tables that like reference the user ID or reference the account ID in another sort of money app. We need a way to break up the transaction. Thinking through the problem, we realized that although having like knowing that an address, an account exists for a user isn't really useful. Like, you can't see their balances, you can't see their transaction history. Nothing bad would happen. And then when the application crashes and reboots, you have these extra addresses, but you would just like upsert them again, nothing bad would happen, which meant we could separate them out. Since we could separate the address upserts, we need a way to represent separate transactions using the Import.Runner behavior. So I added a layer called Import.Stage that's allowed to consume one or more runners. Importantly, a stage, unlike a runner, can spit out a list of multis that aren't related to each other, which means we can chunk the problematic slow updates into separate multis and run each of those multis in a separate transaction to beat the timeout. To use the stages, we collect all the multis and then run them in their own transaction while we don't hit an error. Breaking up the transaction got us past the timeout problem, but we're still seeing a lot of activity in Postgres. If you open pgadmin, there's this nice dashboards thing where it's like, here's all the processes in thread that the server is running and what they're doing. And looking at that, we just saw a bunch of load from Autovacuum. Autovacuum is run to gather metadata, such as which tuples are active and the cardinality or approximate rows of the table. This sort of metadata in Postgres is how it does its query planning. So like with MySQL, the order that you do wheres or the order that you name indices with hints is used exactly. In Postgres, it's like, nah, computers, man. And it'll figure it out for you. But the way that its algorithms figure out what is the best way to do joins, or whether it's better to do an index scan or to do a sequential scan is based on this data that Autovacuum gathers. Because it is doing that based on like how much of the table or the index can fit into the cache, how much of it can fit into main memory, et cetera. And so we can't turn off vacuuming, even though it seems to be putting a lot of load on the server. We need a way to make it vacuum less. What we determined was happening is that although onConflict prevents errors and allows us to updates, it is always writing. So even though an account may already have been known, you know, they may have had the account open for months, for years, we are still writing the row like it's new with that onConflict. So we're doing tons and tons and tons of writes, especially for really popular accounts. Like if you think it was like a business account and, you know, individual people are giving money to that business and it's paying its contractors and in and out, that thing is getting tons of traffic, and every time the onConflict is writing it like it's a brand new account that has never existed before. It's creating a new entry in the table. You know, it's taking up new space on the SSD. And so that means under the covers, those are called tuples. And so those tuples are the individual versions of the rows that have like the numbers in the multi-version system for Postgres. And so that's what all the problems are about. Thankfully, Postgres and Ecto are once again great. Ecto query, we can pass to onConflict a query that has a where clause. Only when the where clause is true will the onConflict actually write new tuples. This will give you weird return results where if the onConflict doesn't trigger, you don't trigger a write, so you won't return those rows. So that means like if you previously expected your upsert to always return the account because it was like your signal to broadcast to Phoenix over a channel like there was a change to the account, and like it turns out that there is no change because the where clause says don't change the row, you won't like get that row back to broadcast it elsewhere. So like you have to be able to handle that. But this will lower, if you have really popular rows that you have on conflict for, this will just eliminate those changes. You'll still have to check that it shouldn't happen, but you won't actually do the write, which means it eliminates the vacuuming. Postgres has a useful operator is distinct from that can be used to compare the updates to the old values. Is distinct from is better than not equals because it does not propagate nulls. By the standard of SQL, null kind of works like not a number does for floats, where if you do any operation on null, the output of the operator is not a Boolean value. It too is null. So it is propagating, which means that if you want to be like, if you have a column that could have been null or an input that could have been null and like the table is already a real value, you can't do does not equal because it would just be null, not true or false. But is distinct from will give you nice clean values. You can compare null to itself like it was a real distinct value. Is distinct from also works on tuples. So instead of to chain together fragments with or, like I was doing here, you can just have a big long tuple with all the new row stuff, like excluded, and all the old values, which is all the ecto column variables there. The only downsides to this is it is very long. So the only reason I got the count and like the order right for this is I copied. I don't remember if I started with. I copied all the column names and then pasted it and then changed one of them to transaction, one of them to excluded to make sure they lined up. But like you can see, this is like over, like it's like 15 columns, and like it's all positional because it's all just question marks. So it would be very easy to screw this up. So it's something you have to weigh whether you feel having the more verbose way is better for maintenance, or this is better. The benefit of the tuple way is you're sending less actual like SQL to be processed by the server. And that can be a problem when you're doing large bulk inserts. We actually got to the point where we just cut it off, where if we were doing more than 500 rows, we chunked it up, because sending more than that many like individual row updates with all those question marks for the bound parameters would actually hit a limit that Postgres is like, the query's too long, you're outside the buffer limit, we're not going to process it. So sometimes picking the more compact way is better for bulk operations. So the final version of the ETL process ensure only unique parameters are getting to the load step using maps or map sets with explicit merge rules that match your update steps, that match the updates in SQL. Validate the params and extract the valid changes from the change set structs. Order the inserts across tables so foreign keys are guaranteed to reference existing primary keys. Break up the inserts into transactions that will insert in a reasonable time to prevent timeouts, but still allow recovery on reboot. Use multi-run to group operations across tables into a single transaction. For each insert or update, sort the changes to prevent deadlocks. While inserting, use onConflict to upsert. Don't use replace all, but instead use ecto.query for better than last write wins rules, which can use the excluded meta variable to refer to the new row. To prevent slowdowns due to autovacuuming, use the where clause on the onConflict query so you don't write rows unless a change has actually occurred. If you have any questions, you can contact me by email or on Twitter or the Elixir link stack as Chronic Death, and you know I host this meetup. Okay, here in person now. Questions? I can go back to slides if you're like, I remember a slide, but I can't remember my thought about it.
If you click through the slides, like just from the beginning, because I know I had some questions earlier, so I might remember. Okay, can you go back one more? There. Sorry. Okay, so I'm trying to understand what's going on with that binary pattern match with what looks like a function call in it.
Oh, yeah. So the binary syntax in Elixir is you can have any number of like specifiers, and they're dash separated.
Right.
Like for a while, the syntax was a list, but the problem was people thought you could like put a real list, but it has to be a compile time list. So like they went with this syntax so people wouldn't think it was a list that they could just include like atoms in and make it work.
Okay.
If you're like, it's weird, yeah, it's weird on purpose to prevent a bug that people were doing. So
it's basically like a.
So this is like big endian. Integer turned into an integer. So like you could have little here to make it a little endian integer if you were doing like integers on I think Intel is little endian technically. Or maybe it's little endian is used in some places. Yeah. MIPS can be either. MIPS can also be shared. Intel also has modes where like when it's 2 bytes wide versus 4 bytes wide, like the order is different. It can be weird. Size. So size and units are just multiplied together. So you can do whatever you want with that. You could have the unit is 3 and do some weird multiplication. But since like I just want to be very explicit that I'm talking about bytes, that I'm going to say size is used for byte count and units is used for bit count. And so this is just saying that like this overall is just how many bits I have to make this number of bytes.
Okay, and
like technically saying it's a big integer isn't really necessary. I'm just doing that to be consistent with like the ones here, so the pattern looks the same.
Okay.
Like because I'm being like I don't care, the fact that it's a big integer doesn't matter. Just the actual bit width is what matters. That's just for me to read to remember why I did that.
Okay, and so byte count, that is not calculated at compile one, right?
Not for this, because I didn't want to do a macro. I could have macroed it. So like in our case, you wouldn't have to do an Ecto.Type this way. In our case, we had multiple hash types. And so we were going to have variable width. Like for any given type, we didn't want the type to be variable, but we wanted to be able to use the hash struct with different sizes. And so like sometimes it's 32, sometimes it's 20, sometimes it's something shorter than that. I forget what the other size is.
Okay.
But like this was so we can control that. But no, this is not known at compile time. Like patterns can be variable for binary patterns as long as they're known before the pattern happens.
Okay.
The thing you cannot do is like in one part of the pattern, get the size and then reuse in the binary pattern, which that comes up a lot and it's super annoying where like you have one argument to a function.
Yeah.
And like you want a binary pattern here and from the first argument, you use in the pattern, you can't do that. It'd be so nice. So what you end up doing is like getting the value out and then calling again with like the pattern filled in.
Okay.
It'd be super helpful if you do it, but you can't because as like Erlang doesn't have a standard, like the beam is the standard for Erlang, but as like a general rule, the way you're supposed to interpret patterns is you don't know the order that they're executed in. And the compiler is free to reorder them. So you can't be like, the first argument will happen first, and therefore I know its type and its value, and therefore I can binary pattern match it. What it actually do if you had both at once is like, you'd be like, vary this over all integers, and if you get one that matches, then the pattern works. And they're like, nah, we're not going to do that. It's the same reasoning why you can't pattern match on a key that's unfixed on a map, like as a variable, because you would have to accept all values, because both of them have to match simultaneously. And then only after the fact you check that their values are the same.
Okay.
Yeah, binary is unsized. So like if I
Wait, so were you saying just now that where you pattern match byte count on byte count, that byte count has to be fixed?
Yeah, when you write it, so it's fixed because at this point its value is fixed here. So not compile time, but as when this line is executed, it's fixed.
Well, do you have to have the pin operator there?
Not in these sort of patterns. You don't pin in these. This one you do because this is a binary pattern. This is matching a value of a map, and that does. Because if I don't pin here, it'll just whatever value byte count has, it'll be like okay. All that would happen if I don't pin here is you get a warning. Variable byte count is unused. So if you look at the code, you're like, why is it unused? Oh, I forgot to pin it. So like that happens a lot to me where like you look at it and you're like, so this will happen a lot like in tests where like you do an assert receive and you forget to pin the value to be like the value you sent to the process you expect to get back. It'll be unused variable. And so like, and then what it realizes is like your test passes because if you don't pin here, any value would be accepted.
Gotcha.
So like if I didn't pin here, any value would be accepted. So I could end up with an inconsistent hash where this byte count doesn't match this byte count, which was a bug. Like that's the whole reason why we have this double thing is because it caught bugs where we were doing copy and paste errors or like test setup errors, or we filled in these values inconsistently. So like this was a check. So it feels like a big overhead, but you know like this sort of pattern matching isn't that much, and it's not that much extra memory compared to like the stuff we're doing. So we felt it was a useful cost for like the bugs that we're mentioning. Anything else?
So that was way over my head, but so I've done all the database stuff I've done is with ORMs and higher level stuff. I've never looked at like for high performance things like this.
Ecto is the closest you're going to get to an ORM because we don't have O's.
Yeah, I was thinking about it. So you're talking about stuff that like you couldn't specify these details when you right? Like
yeah. So my background immediately before Elixir was Rails and Ruby. And the problem with that is like theirs is they use active record. And the problem with that is like it is lazy so that like if you access a field and you don't have the loader, it's just like, I'm gonna touch the database. Ecto is such a nice, and you constantly have these problems of like, it is querying the database when you don't want it to. And you can't tell it to stop doing that. Well, Ecto is like, no, you tell me, we get ready, you tell me everything you want to do in the database, and then I will go do it efficiently. And so you end up usually with a much more efficient app, and you don't get 1+n queries, you know, where like I'm getting the actual record, and then I'm getting all its children, and I end up doing n extra queries instead of just getting them all at once with like a, you know, an all, you know, getting multiple rows at once. That happens a lot with active record. I don't know if that's a problem with Hibernate or if it automatically prevents that sort of thing. But like that was a nice change switching to Elixir and Ecto that's very hard to do now.
So would you call this like application specific, or would this be like a layer?
This approach I would use for anything with ETL going forward. Like the fact that insert all isn't enough, like that the takeaways from it of like the ETL process at the end of like the fact that we have addresses, yeah, that's of course app specific. But like if you have, if you have anything where like, if you have anything, like the address is just like our main entry point of like, you know, it represents a person or it represents a corporation or a company. Like if you have any sort of app like that, and then everything is related to that or constantly says, you know, it's referencing that, you probably have the same sort of problems we have where like, that's gonna be a very popular table, everyone's gonna want to share a lock, and you're gonna have to worry about the same problems we did. I mean, we didn't know this was a problem until we kept looking at that dashboard in pgadmin or the performance tools on AWS and being like, why is this one table so popular? And realizing that the foreign keys were killing us. And like, yeah, one approach some people done was like, well, we should turn off foreign keys and we should switch to a non-SQL database. And instead, we understood what we were doing wrong and made it work. But like knowing multi-run should work if you're trying to touch multiple tables, you probably hit that on even things where you're not bulk importing, you know. anytime you want to update multiple tables at once, it's the better approach for Ecto is Ecto.Multi instead of like doing like you can also do repo transaction. It takes an anonymous function, and you do all your work while you're in the transaction. But like, if you think about it, you're doing runtime work in there, like computing results while you're in the transaction. So like, you're holding the transaction open against the database. While multi-run, you can like, I'm doing as much of my work ahead of time and talking to the database as fast as possible, so you're not eating up resources on the database. So like, it's sort of the thing of like, we're getting the work ready together ahead of time and trying to execute as fast as possible so that we don't bog down our database resources. And potentially we save money because like, you're not going to need as bulky of like an AWS node for your database if you're not trying to have so many connections open at once. The sort changes is like, you're probably going to hit deadlocks if you have multiple writers. So the reason we have multiple writers is we're using you know, tasks that are just built into Elixir to spawn multiple tasks, usually between like 10 and 40 for each API we were hitting. And so like we were having at least 10 writers, but then we ended up with at least 5, maybe like 7 different writers. So like because we got up over to 100 connections, and each one of those would need like 10 or so. Yeah, we had a lot of writers. But would you need it necessarily if you weren't bulk importing? Like if you just, so like you could get the same amount of load if you had a very popular app that was powered by humans. In our case, it was, you know, making an explorer for humans to look at slowly for a remote API that like getting historical data was hard and slow. So we were a cache so that humans could look at historical data that like the remote API didn't want to do. So like if you have a sort of thing where like you have a remote API and it gives you the like 30-day, the past month of results, but it charges you 10 grand to get the next month, this sort of approach would be useful. You know, we're like, I'm going to blitz and like DDoS that remote API to get the data out, and then I'm just going to sit and have a cache. So like a lot of the app that I don't get into because it's not Ecto related is like tuning those number of tasks and like doing back off was a big part of the application of like, because if Elixir can run so much stuff in parallel with its, you know, the processes in the beam that we kept knocking it offline, just having 2 of us test at the same time. So like we had to down tune it. So like in production, it would be up tuned, but like on our dev boxes when we were, you know, testing stuff against the remote APIs or even the test versions of the remote APIs, that we wouldn't DDoS them. Well, DOS is one IP, but still.
So here's another same thing with the pattern matching on the binary. So like whenever I use like an ORM database, the column, like the schema has a type for all.
Oh no. Ecto.Type is just if you want to make your own type. So we could have just said it was binary, but like the reason for that is we had multiple binary types and we wanted to be able to tell that they were different.
So like you could just like mark it in the schema of the table and say this is a 0x prefix X decimal string, or this is raw binary.
No, you can't invent classes. You can't invent types. The only type you can make as a user in Elixir are structs. And the only way to get a struct that is understandable by Ecto is to make an Ecto.Type. I don't know how highbrain works. Like, do Java classes just work like? Don't you have to do annotations to be like these are the fields on the class that actually map to the database columns?
Right.
So it's sort of like that. That'd be your Ecto.Type is those annotations. And so like we had the.
It's a static typing thing. So in Python you have ORM. When you get something out, you don't explicitly know what the type is. Yeah, so
Ecto is Ecto, you like, it doesn't infer the fields by reflectively looking at the database. And that's a choice so that you could like have a very well structured, like your DBA is happy sort of database, and then have like you as like a developer writing like Elixir are happy too, so they're more separate, so that's why they're more explicit. And that's the general approach with Elixir, is that explicit over implicit. So like active record and Ruby on Rails, you'd never say the columns. It's just like, I will ask the table what the columns are. And Elixir and Ecto is like a reaction to that, like, no, that caused problems. We're going to be explicit about the types, and we won't just infer. And it also means that, like, I don't know if you, this comes up in like Haskell making fun of some like stringly typed data, where like you just keep it as a string. And so Ecto.Type is a way to stuff so that the database may think it's a string, but when you pull it in, you can keep it as a struct, so that like you can be like, this string in the data, these are different types, and we can't confuse the two, even though they may in the database be text, because that's all the database can store is text in binary, and even the text is binary, but optimizations. And so the Ecto.Types are a way around that. So there have been other talks at other conferences about like having an Ecto.Type for credit card numbers. Like that's just a number. You could just be just a number, but like, is a number a specific width? Or you could have the text version of the number. Well, it's a specific width. Or it could be like, you always want credit card numbers with a certain spacing, or like a phone number, and you want it as a specific thing, because because people do like the parentheses or the spaces or the dash thing, and you're like, I want to standardize the representation of the string in the database, and I will make an Ecto.Type so that once you cast it once and convert all those things and normalize it, I know, because it's in the struct, that it is always going to be of the type, and I can just make that assumption that it's clean, as opposed to a string where I'm constantly worried that someone put in fully and like non-normalized data. Like, this is a way to normalize the data too. Yeah, so like me even knowing about Ecto.Type came from those previous talks where they talked about doing it for like national identifiers in some other country, where they wanted to. They initially had it as a string, and then like they went to Ecto.Types and just cleared up a whole class of bugs by having it be not just a string, even though it's just representing human readable data as text. The fact that having it separate type fixed a lot of problems. And it also means that if you have one function that is supposed to, like if it's a string, you would constantly have to pick it apart and be like, oh, are you a national ID or credit card number? Well, if it's a struct, you just pattern match on the struct, and that's a much faster dispatch. It's checking on an atom field of a map. So like the code runs faster knowing that it's that type already. I mean, the same reason why strict typing languages can dispatch methods faster, like in Java, is like the type is known. Not as fast as not known at compile time, but like the Erlang compiler can compile pattern matches to be faster that way than like having to test the internal string functions.
Is pattern matching, I take it pattern matching on a struct, I guess that's faster than pattern matching on like a map with string keys?
Yeah, because string keys would have to do, the equivalent of C's like string compare, so it's going to be as fast as that. So like, it could be prefix match to be like they're not equal. But it is, Unicode comparison, so like that could get gnarly. Although I guess equals is strict equals, because like you'd have to use string equals to be like, these two graphemes are the same because they're denormalized Unicode. While if the map has atom keys, or it is a struct, which is just a map with a double underscore struct key for like the name, that atom is stored as just a tagged integer. So it's just doing an integer compare. So like if whatever width your thing is, so like it's either going to be a 32-bit integer or a 64-bit integer. If these are the same value, done. While for a string, assuming it was all ASCII, you would only get the same amount of comparison for strings up to 4 characters. Because 4 bytes would be the same size as an integer, or up to 8 bytes. But in general, no. So the way to be like, do I have string maps or atom maps is external data is strings. I do not trust it. I don't want to create atoms because then they just sit in that atom table for fast lookup. So it's like an intern string in Java or Python where like, as soon as you make an atom, it is there for everyone to reference quickly by ID. And so that just sits there and doesn't get garbage collected. And so once you validate, so in the case of Ecto, like do cast, then you want to switch to atom keys to be like, it's good. But anything where like you switch from external input to like, I now trust this data, you switch to atom keys because the comparison is much faster. And it also signals to people reading it that like, I can trust this data and I don't have to be like double checking whether it's messed up.
Okay.
Anything else? Okay, okay, you join. Let's start. So, what's your name?
James.
Okay. What's your background with Elixir?
Oh, I'm a computer science student.
You could go to the Haskell one, and because Dijkstra yelled at the university when they stopped teaching Haskell. I don't know if you read that. It's a pretty famous like letter he sent to the university.
Yeah, my.
Dijkstra did?
Dijkstra used to teach at UT. I don't know if he still does.
Yeah.
Oh, okay. But yeah, so like UT used to teach Haskell as the intro course. Like University of Minnesota, at least the honors program taught schemes. So like a lot of intro courses are like your one functional programming language course. And that used to be the case at UT, but now they're just like Java.
Yeah.
So yeah. But yeah, the Haskell meetup's good. You should go.
When is the Haskell?
I'm not sure. It's on meetup.com. So. Yeah. Kotlin meetup is tomorrow.
Which meetup?
Kotlin?
I don't know what Kotlin is.
It's a language that JetBrains made for the JVM, so it's like nicer Java, but not as complicatedly different as Scala.
Huh.
Like it's good enough Java that like, so Google used to do Android development on Eclipse, and like IntelliJ was so much better than the Eclipse experience that now Android Studio just is JetBrains IntelliJ, and they now at their conferences for Android development push Kotlin because Kotlin has better, like the code is nicer to work with the Android APIs because it's less code to write, and there's also type inference. So like you don't have to type annotate as much stuff.
Yeah. Yes, I can get really on Java.
It also has what they call the Elvis operator, so that oh yeah, and it keeps track of nullability in the language. And it has an Elvis operator, so like if something's null, you can then do something else. And it has like that paired with like lets, so like and
Is it different for optional?
yeah, so it is literally using null, and you know like Java optional is like literally a class instant, an object that is optional. Like it's not, well, Kotlin's is just the compiler's keeping track of whether it's null or not for you. You can switch to optional, but like the reasoning for that was they wanted to work on Android, and like at the time, that meant targeting Java 6, and optional wasn't there, and so like these were some compromises they made with Kotlin to do it. That's very nice. I actually write the IntelliJ Elixir plugin mostly in Kotlin now. It's very nice. Like I do like Elixir style pattern matching, but in Kotlin using what they call the Elvis operator, which is like question mark colon, where like if this first thing was null, try this something else. And it's a very nice way to write pattern thing. So since you're a student, we could bug Jim Freeze to see if you can get a super cheap free ticket maybe to Elixir Conference if you're interested, but it might be Friday and Saturday, so that might screw with school. So are you on the part of operating systems where you have to do threads, or the one where you have to write your own shell? Okay. Yeah, I remember that one where it worked on my laptop, and then I put it on the lab machine, and it's like faulty because I forgot to clean up in the right order. It wouldn't like it shut down. Thread sucking is why I do Elixir. Actually, no, MRI sucking and threading in Ruby is why I do Elixir. Like, I could not make it work well because old interpreter locks suck. Yeah. So next month, unless there's a topic suggestion, we'll do what we normally do during after conferences is go over the talks, explaining which ones were good, which ones you should watch, and Jim's conferences are very good about getting the videos up very quickly, so there's a chance we will show clips of the sections of talks that we think are worth looking at if you don't have time to watch the 2 days worth of talks. So what is that? It's not that many, it's like 11 or so, but it's still a lot of hours to watch. Lone Star Elixir Conf.
Oh, I see so much on YouTube last year.
Yeah. Yes, this is the talk I'm going to give. This is my practice space. So yeah, if you're like, that was really hard to understand, or that sucked, please tell me now, so that I can fix it for everyone else that paid next week.
It seems like I would have understood if I did this stuff.
Yeah, I was judging whether to explain Ecto because like people that Elixir know Ecto, but like people that are like, I'm going to learn Elixir and I'm going to do a conference first. So I was thinking, it looks like I might have had time. I only have 40 minutes, so it's not like I have 2 hours like I have during the meetup to do it. So maybe I had enough time in there. Because it looked like I had some duplicate slides, at least from the speaker note view. So I'm able to fit in more time to explain what is Ecto.
I felt like you were speaking a little bit fast at times. And I felt like it would have helped me if you would like pointed to the thing on the slide that you were talking about it.
Yeah, it's easier in the actual spot because like I'm not sitting down. Yeah, at the actual conference it's easier to do. Well, yes, I always speak fast, but thank you. I will try to remember again. Yeah. Okay, so you two are connected for George. That's good.
Yeah, it's not good, appreciate it.
Yeah, we'll reach out to him.
Yeah, at least for coffee or whatever.
Yeah.
Sounds like you guys are pretty deep into the Elixir. Seems like there's a bit of learning curve there.
Yeah, I'm actually the one with the company who knows Elixir.
Oh, okay.
If you need help, I work at Dockyard. You could hire us for a little bit for consult, or just you need it and can afford it.
Well, so we're not at a point right now where like basically I'm managing to do everything that we need, so I don't think we'll actually have to.
If you feel like you get stuck, or you can just hire like for like less than a week to get like Chris McCord or Paul Schoenfelder to do an architecture review to be like change this, and this, and like your speed problems will go away. That's also like you don't have to hire us for months. Like under a week could work for you. If you hit a roadblock where you're like, this is impacting the business, and I need someone to help speed this up, like you could do it for that too. Do you need internship information, or are you good?
Awesome.
Merck has an internship program. They're not, a tech company, but they do tech, and they have a lot of varied stuff. But since they're a big enough corporation, they actually have internships. National Instruments is good. They actually use Elixir for some stuff. They are using Elixir for the automated web services that they make for people that use it's not MATLAB. The thing that they use to plan like lab stuff out. LabVIEW, yes. So National Instruments, like just in the past few years, started to do where LabVIEW flows can like now have like web APIs or like web views, and people were like, I don't want to be a web programmer. National Instruments, can you do this for me? And they're like, yeah. And so like they have this whole Elixir thing to do that. But also, MATLAB and LabVIEW in general are super cool. MATLAB is actually on the little Lego robots, because the National Instrument guy said that is that like LabVIEW is actually running on the Mindstorms by default, because it made it easier for robotics competitions to use Mindstorms. So it's like 10 grand worth of LabVIEW software on each of those Mindstorms, like the equivalent of like licensing the features they put on them. It's kind of cool. Okay, well, if there's no more questions, we technically have the space for 21 more minutes, but we can call it a night. If you want to just chat, discuss job stuff or anything else, we can also just go down to one of the various bars and get stuff to drink.
I'm down.
Okay.
Yeah.
I'm gonna do 29.
Yeah, that's very good.
Right.
Thank you.
Oh, we can.
No, I'm all right.
Okay, we can sit. We don't have to sit literally at the bar, and you'd be able to come with us.
It's fine.
Okay. Okay.
Good luck.
Bye, everyone online.